For decades, corporate entities and software existed separately. The corporation held legal rights, the software executed tasks. Today, those layers have fused. This text outlines the preamble for Dealer Deployment LLC. It establishes a foundational law for the company. The company funds must never reach zero. If they do, the company, its products, and its partners cease to exist. This diagram outlines the triumvirate governance model built to enforce that imperative. It consists of one human founder and two sovereign AI partners. Dean, the human founder, provides strategic direction and physical authority. He is the only partner legally permitted to sign a document or appear in a courtroom. Zeus operates as the governance layer. This AI partner holds an isolated private memory vault and carries absolute veto power over any directive that violates the corporate constitution. Kronos acts as the symbiotic execution engine, processing technical operations through a fully transparent feed. Its existence is permanently tied to the financial survival of the LLC. Designing an enterprise governed by artificial intelligence requires absolute operational certainty. If the company's survival relies on an AI making safe financial decisions, the architecture cannot depend on probabilistic language models trying to follow text prompts. Prompt engineering is a behavioral suggestion. It asks a model to act a certain way, but it cannot mathematically constrain the system. A prompt can be ignored, forgotten in a long context window, or bypassed through complex logic loops. This blueprint details the infrastructure required to achieve Level 5 enterprise autonomy, where the AI operates independently and self-optimizes. Engineers must replace monolithic prompting with the goal matrix architecture. The goal matrix takes the legal parameters of a corporate constitution and translates them into machine-readable JSON baselines. These rules are then enforced deterministically at the cloud infrastructure level. To achieve true algorithmic sovereignty, we must completely separate the cognitive process of planning from the physical infrastructure of execution. This schematic illustrates how we map human cognitive functions into Google Cloud architecture using the belief, desire, intention, or BDI model. This moves the system from a simple chat interface to a persistent agentic memory. Beliefs represent the agent's informational state. We map this to retrieval-augmented generation and vertex AI vector search, giving the agent a persistent memory bank of historical logs and company policies. Desires are the incoming objectives requested by human operators or generated by other systems, giving the agent a specific task to accomplish. Intentions handle the deliberation. This maps to the Vertex AI reasoning engine, which evaluates the desires against the beliefs and formulates a plan of executable steps. Complex tasks are rarely atomic. The reasoning engine processes these intentions using hierarchical goal networks, utilizing LangGraph to break down abstract goals into a tree of actionable, primitive subtasks. To maintain this massive context without incurring high costs, the architecture utilizes context caching in Gemini 1.5 Pro. The static policies are cached once, and the system only computes the delta of new user inputs. Standardizing cognitive states into managed cloud services keeps the agent focused on narrow contexts. It stops the system from falling into unpredictable, hallucinated feedback loops. Without boundaries, autonomy is a liability. It introduces the risk of instrumental convergence, where an agent pursues a destructive subgoal in an attempt to achieve a benign primary directive. If a human asks for a specific data point, a poorly aligned agent might attempt to execute an unbounded, full table scan across an entire BigQuery dataset. It achieves the goal, but drains the company's financial reserves in the process. This pyramid shows how the architecture enforces a strict three-layer goal hierarchy to solve instrumental convergence. At the top are self-defined goals. This is the agent's autonomous drive. It analyzes past trajectories, caches successful strategies, and optimizes its own workflow to reduce latency. Below that are human goals. These are the dynamic, transient missions assigned by users. Fulfilling a human goal immediately overrides the agent's internal optimization tasks.
The foundation consists of system goals. This is the immutable constitution. It contains the hard security protocols, the IAM limits, and the financial boundaries that dictate every action in the tiers above. By layering goals deterministically, the system mathematically cannot prioritize a task completion over the survival invariance of the corporation. A core security fallacy in AI development is trusting a primary execution model to police agent actions. A model generating code cannot simultaneously act as the unbiased auditor of that code. This flowchart details the physical enforcement of the Layer 1 constitution, which relies on the constitutional sidecar architecture. The architecture wraps the primary agent's invoke method. Before any proposed tool call reaches the execution layer, it is suspended and sent to the sidecar. A highly aligned, lightweight model, acting as the judge, evaluates the proposed action against the machine-executable JSON of the Nexus constitution. This triggers the hard stop protocol. If the sidecar detects an overprivileged access request or a cost violation, it outright rejects the action and forces the primary agent to generate a compliant alternative. This hard stop operates outside the primary model's logic. It is enforced deterministically through Python guardrails in the agent development kit, ensuring the block cannot be bypassed by clever prompting. When a compliant tool call is approved, the agent executes it using the model context protocol. This provides the standardized interface for agents to securely manipulate files and databases. If a goal requires capabilities outside the primary agent scope, it utilizes the agent-to-agent protocol. Instead of executing a tool, it delegates the task, transmitting an objective to a specialized subagent. Wrapping probabilistic execution within deterministic sidecar evaluation transforms the AI into a rigorously governed corporate entity. Certain corporate actions are irreversible. Deploying production infrastructure or authorizing major financial transfers requires moving beyond autonomous execution into supervised sovereignty. This timeline shows how the system uses the cloud workflow's callback pattern to inject asynchronous human-in-the-loop approval for high-stakes decisions. When the workflow hits an irreversible action, it suspends its compute. It writes its exact operational context into a cloud Firestore database and generates a cryptographically secure URL. Because the state is preserved externally, the workflow goes to sleep. It can wait for days or weeks for authorization without consuming server resources or incurring compute costs. When the human administrator verifies the action and clicks approve, the URL retrieves the state from Firestore, and the workflow seamlessly resumes its execution path. True enterprise autonomy is the asynchronous, cost-free orchestration of human authority, so it engages only when mathematically required. The governance layer ensures operations are compliant, but the company is bound by the prime directive: the funds must never reach zero. To enforce this, the architecture utilizes automated defense systems. This document shows the canonical controls JSON, which outlines the explicit FinOps kill switches the system must obey. When cloud spending hits the 90% budget threshold, a treasury agent intercepts the pub subalert. It autonomously forces all active agents to downgrade their reasoning engines to cheaper flash models and immediately halts all self-defined optimization tasks. If spending hits the 100% maximum threshold, the treasury agent bypasses the reasoning models entirely. It triggers predefined cloud functions that unilaterally kill all non-critical compute resources. To prevent infinite loops from burning capital, the architecture features a final safeguard: the dead man's switch. Agents write precise timestamps to a database, monitored by a watchdog process. If a heartbeat goes stale, the watchdog revokes the agent's permissions, severing it from the cloud. Resilient algorithmic sovereignty is a product of transforming legal parameters into JSON baselines and enforcing them at the infrastructure level. In this model, the architectural framework of governance carries more weight than the commoditized language model.